In the question number 31, 2 mole of an ideal monoatomic gas. In the case of thermodynamics, you have to be very careful. Number of moles and type of gas, mono, di and tri, taken from A to B. The change in internal energy of the gas during this transition. The change in internal energy of the gas during this transition. So we know PV equal mu R T. And you know the change in internal energy in the case of ideal gas depends upon only temperature. So first I would like to know the temperature. It is going to change or not. So if I use, so we will write PV upon T. If you are looking to find the value of temperature or nature of the temperature, it is going to change or not, I will use pressure at A, volume at A, temperature at A. Similarly, I can write pressure at B, volume at B and temperature at B. You know the value of PA is 3, you can see by the diagram. So I will write here 3 into 10 to the power 3 and volume is 1, you can see on the x-axis, divided by temperature TA. Similarly, at the point B, the pressure is 1 into 10 to the power 3, but volume is 3 and temperature is TB. So you can cancel. So easily you can find TA is equal to TB. So if I go for the change in temperature between A and B, you will get 0 because both temperatures are same. So there will be no change in temperature. As I said, change in internal energy in the case of ideal gas depends upon only temperature. So we can say the change in internal energy will be 0 because there is no change in temperature. So I can say my option number 4 will be the right choice. Let's move on question number 32. In the question number 32, for a gaseous system, if heat rejected, you have to rejected means negative heat. Work done by the system means positive 20 joule for the change in internal energy. So you can solve this question by using first law of thermodynamics, change in internal energy and work done. You have to be very careful regarding sign convection. Heat rejected will be minus and you need change in internal energy. Work done will be positive. So when you will calculate, you will get delta U minus 120 joule. So easily you can solve. In this question, the message is only one, sign convection. So my option number 1 will be the right choice. So let's move on question number 33. When two bodies A and B are in thermal equilibrium, then before going to read the option, I would like to repeat, if two bodies are in thermal equilibrium, then both the bodies are at same temperature. If temperature is not going to change, then there will be no change in internal energy. So if I read the option number 1, internal energy A must be greater, no, false. Internal energy A must be less than of B, no. Internal energy of A must be equal to internal energy of B. डिसाइड करने से पहले 4 पे चलते हैं. टेम्परेचर ऑफ ए मस्ट बी इक्वल टू द टेम्परेचर ऑफ बी. यहाँ पर एक कंफ्यूजन है, हम थर्ड को क्यों नहीं ले रहे? बिकॉज एज आई सेड, इन द केस ऑफ आइडियल गैस, इफ गैस इज रियल देन internal energy will not be depend only temperature because you can count potential energy also. But in the case of thermal equilibrium, we can say the temperature will remain same. That's why we are confident temperature of A must be equal to temperature of B. That is why I am neglecting the option 3 and I am going to select option number 4 will be the right choice. So let's move on question number 34. In the question number 34, an ideal gas is expanding Pt is equal to constant pressure and temperature. The coefficient of volume expansion of the gas symbol have their usual meaning. So you can solve this question by using, because we know Pt is equal to constant, let us say K. So I can find the value of P in terms of K by T. K is the proportionality constant. Okay. Now we know the ideal gas equation PV equal mu RT. Now if I replace the value of P, then we'll find KTV, and that is equal mu RT. So I can find V is proportional to T square because T से आप multiply करोगे. Now I am going to differentiate, तो dV over V, that is equal 2 times of dt over T. Because I would like to make the formula of volume expansion. So if I write like that, dV V dt, then you will find 2 upon T on the right hand side. And question is asking to us coefficient of volume expansion. You know this is the formula of coefficient of volume expansion. So easily you can find gamma is equal to 2 by T. So my option number 2 will be the right choice. So let's move on question number 35. In the question number 35, in a reversible adiabatic expansion entropy of the system. You know, in the adiabatic process, entropy will remain constant. But if I go for the entropy, then formula is ds is equal to dq over T. The change in heat with respect to the temperature is called entropy. But in the case of reversible adiabatic expansion, you know dq will be 0. There is no exchange of heat. So you will find ds equal to 0. ds means change in entropy. So if change in entropy is 0, then we can say entropy will remain same. So we can select option number 3, will remain same. So let's move on question number 36.